So this is one of the talks coming out of the research track. And I'm not really sure if this area has been properly introduced, so just allow me for 1 minute explaining you what this strange R in bigger brackets signifies in the program. So we actually had two separate call for papers. So we had the call for papers for the so-called industry track, which is just a demarker, and the research track. And the reason is because we are AppSec research, and one of the mission statements of the European OWASP conference is always that we also want to attract the people in the ivory tower of the universities and the proper academics and the real researchers to come out and play with us. And so this is one of the papers we accepted for the research track, for the research call for paper, and it's Lieven Desmet from KU Leuven, and he will tell us about 3 years of research on sandboxing JavaScript.
Okay. Thank you. So maybe before we start, just close the doors or go outside if you want to discuss. So my name is Lieven, and in this last talk of the main track, I actually want to give you 2 insights. First, how are we using third-party JavaScript in our applications? And also report on a study on the top 10,000 websites, how they're actually dealing with it. And secondly, I also want to give you some insights, how do you protect your website against third-party JavaScript that gets malicious. So myself, I'm a research manager at the Ayman Zishtert research group at the University of Leuven. We have a software security lab with about 80 researchers, and we have also a dedicated team on web application security, and some of the colleagues are here present as well. So within the mitigation techniques I will discuss today in my talk, I only will focus on 2 due to timing constraints, but if you have any question about other techniques that are actually spelled out in the presentation, feel free to contact me during the break and we can discuss in much more detail. But first to start, how do we actually integrate JavaScript in our application? This slide should actually not be part of my presentation. Everybody knows if you want to include JavaScript in your application, you can use the script tag. You can actually fetch a remote resource or a local resource and put it as part in your website, or you could just do it in line. What's important to actually say here is the security model beneath it. So what we see here with the script tag and a remote script URI, it means actually that the browser will fetch the URI and then take it as if it was part of the website from the beginning. So it will execute it in the website as it came from the website owner. It will have access to whole DOM, to all the operations, local storage, cookies. It can send on behalf of that website from that client, request, and so on. So there's actually no isolation between scripts coming from abroad or scripts delivered directly from the website owner. If you're looking to any website you're visiting, you will already get some visual clues that certain things are already coming from remote parties, like the JavaScript, like the social media integration. But even underneath in such a website, there are a lot of JavaScripts up and running. In this particular website, I was using tracking and web analytics, but you could have many more. And in fact, if we're developing web applications, we actually use tons of libraries to enhance our application, either from the part of development, either from the part of functionality and visual effects on a web page, or even to actually monitor or do the operations afterwards. The study I will refer later on to actually mentions that more than 88% of all the websites from the top 10,000 domains actually include resources from at least one remote party. It means that at least one remote party is including JavaScript in the websites of the top 10,000. And what actually could go wrong? Well, as soon as one of those JavaScript libraries being included in your application gets malicious, gets compromised, it actually has access to the whole client-side part of your application, and the whole client-side part gets owned. So what is the characteristic of getting owned in such a JavaScript library? Well, there are different versions. Well, of course, your script provider himself, he could become malicious. But what could also happen is that he gets compromised. And it's actually something that we noticed within the Q-tip scenario. Nick pointed to that. If you see this page, actually they mentioned that they were hacked during 32 days, and they were serving malicious JavaScript instead of their own jQuery plugin during that period. So everybody downloading the software during that period, or actually remotely including the JavaScript from this website, was vulnerable for 32 days, and all their customers could get malicious JavaScript. So it's actually real. And in order to give you a better idea of how actually websites are using third-party JavaScript, I will give some results that Nick and his team, together with people from UCSB, were doing during a large-scale analysis of script inclusions. So during their experiment, they were actually crawling domains of the Alexa top 10,000. They wanted to see from those top 10,000 how many scripts are included from their domains, from which script providers, what do they actually do. And for each of the pages, they crawled around 500 pages, up to 500 pages, resulting in 3.3 million pages that were visited. When they were visiting those, they found out that about 8.5 remote inclusions were actually happening in those pages. We can reduce that to 300,000 different unique URLs, the JavaScript files, and that was actually served from about 20,000 domains. So it's actually happening quite a lot in practice. Also interesting is actually to see the distribution of how many script providers are trusted by such a web application. And you see that the thing is skewed quite far to the right. So you see that some of the websites are using a lot of script providers. There were websites up to 295 script providers that were used in order to run their website. And you only need one to get compromised. But you also can see that more than 60% were actually using more than 5 script providers as well. So it's not only 1 or 2 parties, but they're losing several parties and actually trusting for their own website. Also interesting which scripts were included. This is the top 10 most popular scripts that were included in that study. You see the usual suspects. You see analytics, social media integration, advertisements, market research. And what's also interesting to see is, for instance, the top one, the Google Analytics, was included in almost 70% of the websites. And in addition, you could even see that from the top 10, 5 of them came from Google. That means if Google actually wants to own World Wide Websites, with one click, they can actually bring down 75% or more of the websites worldwide. They can actually own any client-side part of the websites by using those libraries. Also interesting to know, can we differentiate between benign and malicious JavaScript? And this is interesting to see because when we see JavaScript and we think about malicious JavaScript, maybe they have certain patterns. They're using eval, they're reading cookies, they're doing other stuff that is not expected to be done. Well, if you look into the top 100 scripts that we evaluated, well, 40% of them are actually reading cookies. They're actually writing cookies. They're using eval. So it's really, really hard to differentiate between benign and malicious JavaScript. And this is an ongoing study in research anyway to actually trying to differentiate between good and bad in the JavaScript world. So we saw about 8.5 million remote inclusions. Interesting next step is, of course, are there other ways to attack this problem of remote inclusions? And well, there is. Nick found actually 4 new attack vectors. And in this presentation, I only will present 2, but there are references to the paper. If you want to read the whole report and the attacks, please go and read on after this presentation. So the first one I want to highlight today is the stale domain-based inclusions. And the idea there is, whenever you are trusting a script provider at the moment of writing and deploying your application, over time, that script provider might stop his service. And in fact, the domain can become stale, and if you could re-register that domain, you could actually take up the place of that JavaScript provider. And we found 56 cases where actually the domain got stale over time. While we're doing the analysis, the domain is stale, whereas probably when the service was put up, the website was actually trusting a script provider running on that domain. So the next step of the team was, well, what if we just start registering some of those domains? What happens? So for the purpose of researching this, they were actually registering bugtools.us and hbo-tab-admin.us. They're running the service for 2 weeks just to see how many requests are coming in for JavaScript. And it turns out for the first one, in those 2 weeks, about 80,000 requests are coming in to fetch JavaScript from the page. And for the other one, around 4,000 requests are coming in. So it's actually real. Just by registering a domain that became stale over time, we can already start serving malicious JavaScript to a whole bunch of users. The second attack is based on typo squatting. You all know typo squatting in the URL bar, where a human actually mistypes a URL and gets actually redirected to a page under control of an attacker. Well, the idea is the users behind the browser are human, but also the developers are human. They can mistake as well. And an instance, for instance, is Google syndication, where they're actually using libraries from Google, but forgot the N. And at that moment, you're actually redirecting to a domain that does not exist. And by now, you, of course, already have a trick. We go online, we register googlesyndication.com, and we're seeing for 2 weeks how many requests are coming in. So it seems that not that only person was doing the mistake. We found domains, about 1,200 domains actually doing that mistake and including JavaScript from googlesyndication.com. Maybe there's somewhere a copy-paste error on one of the wikis or the blogs. And we actually could serve about 160,000 malicious JavaScripts if you have wanted. This was not the only case. There were also other interesting domains, and I really hope that Nick had visited them before publicizing his research. Okay, we have now a better idea what can go wrong. We saw a few attack vectors of how a script provider could get compromised over time. But the main question of this talk is, what do we do to mitigate? Because we want to use all those libraries, we actually want to use that functionality, but we don't want to get compromised in our website. And actually from now on, the bad news start. There is no silver bullet to protect your website against remote inclusions. So what I will do in this presentation is give you an overview of the 3 classes of mitigation techniques that were researched in the last few years. And then I will head you to 2 new promising directions of research where you actually can do coarse-grained or fine-grained isolation based on container or sandboxes. So for the existing mitigation techniques in research, the first class was actually relying on restricting your JavaScript to a subset. It has mainly been used in advertisement, like for ad safety, also for the deprecated Facebook JavaScript. But the problem with this approach is, while it is actually very fine to say we limited it and we can actually do some analysis before we submitting that JavaScript from the server to the client, it requires that every JavaScript should adhere to that subset. If we have the tons of libraries that we want to use in our application, they all have to adhere, and it's very hard to convince script providers to provide such a library. The second class of research was actually, we want to make fine-grained enforcement of third-party content. What do? We actually enhance our browsers, and the techniques like conscript and WebGL actually augmenting the security within the browser. We could have very fine-grained policies, but the major disadvantage of this research area that it requires heavy modifications in the browser. So it's very hard to adapt it. And also there was no consensus on what should be the policy that browsers are enforcing on the client side. And the third category of work is actually the work where you actually use the server to do all the preparation of the script before sending it to the client. It means that your website itself is fetching all remote JavaScript on the server side, doing some verification, doing some transformation, and then sending it to the client. And the most important example there is Google Kaha, who actually uses it on gadgets on iGoogle and also on Yahoo. The drawback of this approach is that you actually need the whole server-side installation, but also that the scripts are no longer directly delivered to the browsers. They always have to be proxied. So if you only can fetch your scripts by using cookies, this actually is disabled by this approach. So let's do in the other avenue. What is actually emerging from the whole sandboxing research? Well, we see more and more client-side security architectures. And what do I mean with that? You actually have your client and server that keep unmodified. What you want to do in the server side is only performing and composing a policy, what you want to do from a security point of view, and then the client is actually enforcing it. And how do we enforce that? We actually use existing building blocks like JavaScript, JavaScript frameworks, or techniques such as CSP and HTML5 to do the enforcement, to do the sandboxing. So you always have a sandboxing technique that makes sure that your JavaScript is executing in an empty environment, and then you're actually feeding in all the wrappers to security-sensitive operations that are controlled by a policy. You have several techniques. You have one based on HTML5 combined with CSP. You have Treehouse, where they're using web workers to actually do the isolation. And you have work that we did in our lab, where we're using the secure ECMAScript library to do the sandboxing. And for the rest of this talk, I will just give you a brief overview how both of those technologies are working to give you a highlight. What are the consequences for my application? How can I actually go forward? The main difference between the two techniques is that the first one can already easily be achieved with the modern browsers being around. The drawback of it is that it's very coarse-grained what you can do. You can either say this part can run or this part cannot run in my application. But it's very good to protect against cross-site scripting if you have user input that you have to execute anyway. The second one is much more fine-grained, but has some limitations in performance and the script it can support, but this is ongoing work in the research community. So the first one is actually based on information I got of the Mike West talk at DevOps 2012 called Securing the Client Side. And And actually, I encourage you to read App on this blog, what he told there, to download the slides, to see how it's actually working in practice. The idea is that we combine an HTML5 sandbox iframe with CSP, and by actually setting up an architecture like that, that you're protecting which parts can run on your own origin and which parts actually run in an origin you don't care about. By now, actually, I hope that everyone already heard from the content security policy CSP, that I don't have to explain it in much more detail. What I want to say about the CSP is that actually what we use in the technology in the architecture here is the fact that you can disable inline scripts, and that you can also make sure that only scripts from your own origin are loaded, so in order to protect you against cross-site scripting. From my personal view, I think it's a very promising and interesting technology, but I would like to warn you that it's actually an additional layer of defense and your protection against injection attacks. So you should use this technique for sure, but use your existing techniques in combination with this technique to have better defenses. Because we already heard today and yesterday that there are some breakthroughs in breaking CSP as well. Now let's look to the architecture itself. The architecture starts with your main site. This is actually the site you want to protect on the client side. So we're all operating here in the client side. This is the origin, your original frame that you're seeing in your browser. What you will do in this architecture is actually set up a separate iframe that is sandboxed, and actually what it means is that all the unsafe executions will continue in here. And what you will do is actually, from the main side, delegate all the execution that are unsafe towards the sandboxed environment, and whenever they are performing any result, you will get them as a web message, via web messaging or post message back to the main side. So the idea is that you delegate all the untrusted things to something that is much more contained towards your own web origin, and can do whatever execution you want, and what you get back is actually sanitized. In order to do that sanitization and safety, you're actually securing your main site with CSP, and then you're delegating all the rest to the sandboxed environment. In order to create the sandboxed environment, you're actually using a sandboxed iframe, which makes this run in a unique origin, but it is still allowed to execute JavaScript. And this architecture view is actually used in Office document reading on Chrome OS as well. If I would judge what is the most difficult part to implement yourself, I would say the web messaging, the delegation between the main site and the sandbox environment. And I will just give you a flavor of how that looks like. We don't go into detail in the code fragments, the code snippets. You have the slides afterwards, you can process them a little bit more space as well. So the first one will protect with the content security policy, so that means that you will have to issue this via response header or via your meta directives. And what you do is actually setting up an iframe, and it has the sandbox attribute that it is allowed to run scripts. So this is actually setting up the red container I discussed on the previous slide. Next, what you'd have, this is the container actually running in that iframe. You have a window listener that is actually getting all the information in from post message. It can call whatever unsafe function it wants to call in this isolated environment. Since it's running in a different origin, it cannot access your DOM, it cannot access your cookies, it cannot access your local storage, but it can still execute whatever it needs within your web browser. The result itself is sent back to the original origin, so to the main frame of your website, and that's the only processing that happens in the red box. Of course, in your main page yourself, you have to actually do the delegation back and forward. The first one is actually sending the commands to the inner window, and here you're actually containing the results back from the inner window and putting them in your main window. What you do here with actually putting it in the main window, this would be considered unsafe because you are doing inner HTML, and whatever result you get back from your sandboxed environment could contain inline scripts, could contain additional script tags to load scripts, but because you're running in a CSP protected environment, this will actually be mitigated. So even if there are inline scripts in the string that is being attached here, that will be rendered useless by CSP. And this is actually the main trick that has been done in this delegation model. That's also the reason why it's actually very coarse-grained. It means that you can protect this string of having JavaScript inside, but you can't say to protect which operation it can be used. So it's not possible to say, I allow it to read some parts of my local storage or having access to my cookies. It's either you can run in a complete isolated environment and give me something back, and that's the only thing that you can do with this kind of architecture. But still, I think it's very useful in a lot of cases, forums or anything else where you say, I have user input, I want to render it in some form, but I want to actually mitigate what is the impact on my own application. Okay, I want to stop with this technique here, and actually I want to have a very quick look forward to JSON. And there we're actually having the server-driven sandboxing of JavaScript. Again, you can read up with the paper mentioned here. And the idea with JSON is actually that the server side has some policies on how to compose JavaScript in your application, pushes it to the client side, and there you're actually building up a whole JavaScript architecture. So you're building up a security architecture composed of JavaScript components, which is able to load additional components in a sandboxed environment. So if you're looking what we want to realize with this technique, you have your website, you have some JSON component on your website, and you want to include JavaScript 1 and JavaScript 2 from two remote providers. So one might be malicious, someone might be trusted. We don't care. What is important is that for each of those, we have a policy that expresses what that script is allowed to do. And with that information of what that script is allowed to do, we can actually bootstrap the whole loading process. What we want to achieve is that within our browser environment, JSON gets loaded. The different JavaScript components are getting loaded, but they're running in an isolated environment controlled by each of the policies. How do we realize that in JSON? We start with the embedding page loading the JSON framework. That is actually loading up all the initial components, the building blocks that we need to do the sandboxing and wrapping. Next, we're fetching the third-party JavaScript from a remote site to actually enable it to be loaded in such a contained environment. We're setting up the contained environment. We're actually providing access from that contained environment to our own DOM via wrappers that are controlled by a policy. And then we're actually starting to execute the third-party JavaScript. It's a little bit more complex than I presented here, but in the paper there are much more details of how we're using the technologies. What's interesting to actually tell is actually which of the components that enable this. Well, there are actually three components as very important building blocks that enable this kind of sandboxing technology. The first one is a client-side library called Secure ECMAScript, and it's developed by the Google Kara team. And what it does, it actually provides you such an isolated environment. You can load any snippet of JavaScript as part of that environment, and you only can define what access that script has. And it's very limited by default. But of course, in order to actually give it more functionality, more access to surrounding APIs, we need to provide the wrappers. And we do that by actually combining proxy APIs. And proxy APIs allow you to transparently wrap around an existing object in your JavaScript DOM tree and actually provide that towards the sandboxed environment. And secondly, we're applying the membrane pattern, and that's just actually the policy that we enforce within the proxy to make sure that we never break out of this sandboxed environment. And the combination of those three technologies with some engineering layer on top of it in order to make sure that legacy scripts can run in this environment, make sure that we can actually use JSON. How does it look for the developer? Well, for the developer, we wanted to mimic the normal environment and match it as close as possible. So what we see here is actually some JavaScript code being syntactically combined in JSP tags. It first starts with loading the JSON framework. Then we're actually loading a JSON sandbox, giving it a policy that is described in the context descriptor of our application. And then we are actually able to load additional code snippets in that container. Similarly, we can have a sandbox where we have a policy to run no geolocation. It can already preload some of the APIs we have within our container. And then we can add additional code snippets as we do with normal script tags. We can also load additional remote scripts to be loaded as part of this container. For now, we tested it on a few scripts, and we tested it on Google Analytics, Google Maps, and jQuery. With some engineering support, we were able to run all three of them in a quite successful way. But still, we have some performance issues that we have to tackle, and we also see that there are future advances that we need to do in order to make this practical on a daily visited website as well. If you want more about what's the status of this prototype, come and see me after the talk, and I'll give you all the details about the status of JSON. Also, if you want to try it out yourself, you can actually go and visit the demo that we defined at the FP7 project website. It's called demo.jsand website.eu. And actually, it says the instructions to run it For now, we actually have a version that is actually tuned towards Firefox. So you actually use your Firefox, you go to the web page, and you will already see that we have some scenarios to show how you can run Google Maps. You can run two Google Maps next to each other, each with a different policy, and so on. So this brings me actually to the conclusion. So this was a very compressed talk about a lot of research we have been doing in 2 years in our research group within the Web Analysis project. And what I wanted to bring you today is actually giving you some insights how we're using third-party JavaScript. So let me remind you that more than 88% of websites actually do integrate content coming from this external script provider. And by far, Google is the absolute #1 script provider in webland. Secondly, we see malicious JavaScript appearing over and over, but you have to think about different attack vectors to actually how that JavaScript is delivered to your website. The script owner can become malicious, he can get compromised, like we saw in the Qtip example, but also there are several new attacks that were defined by Nick and his team in the paper that they did on the large-scale analysis. Think about the two tricks that we did by registering domains and actually getting traffic to our domains. Secondly, on the mitigation side, we should have brought you the message that actually none of the existing techniques is actually the silver bullet. Most of them have quite some work that you have to do on your application to get it up and running, or they have limitations in their deployment. So some of them might require browser modification and actually deep browser modifications that we can't accomplish with extensions. Some of them require server-side processing like the Caja. Some of them require to re-architect the application like we saw in the example of CSP combined with Sandboxed iframe. And some others have actually restrictions on the JavaScript, the language feature that they can use. Nevertheless, I think I showed you two promising directions of actually how we can sandbox elements in our page. I think the first one is the most practical one because it can be easily used already on the new browsers. You're combining iframes and CSP, and you could even go further and define different origins. You could actually elaborate on the security architecture on your client side. The second one is using new techniques in the JavaScript landscape, also available already in the modern browsers such as Firefox and Chrome. And with that, I would like to end my presentation and I'm open to questions. I would like to acknowledge all the European projects actually supporting this research, and I hope you learned something from this. Thank you.
Thank you, Lieven. So, are there questions in the audience?
So everyone is getting tired, probably.
Everybody's getting tired. But you should still stay awake because we have still a very exciting closing note ahead of us. And so I would like to thank Lieven again. And
thank you.